So Thomas wasn't the only one who wasn't exactly a believer in certificate transparency. I joined Google almost 3 years ago to the day, and I took over as product manager for Google Certificate Authority and certificate transparency roughly around that time. And before that, or at least a year before that, I was at a reasonable-sized commercial CA as the CTO. And when I saw certificate transparency, I said, neat trick, but it seems like a lot of work. And so I think my position was pretty similar to Thomas's. But I have fallen in love with my child now, my adopted child. So that's what I'm here to talk to you about today. So some of this content to you is probably old hat, so you'll have to bear with me a little bit. But all of this boils down to how sessions on the web are encrypted. So let's start with, I have a Gmail account and a Hotmail account because I spent too much time at Microsoft. But let's start with Gmail. So when we open up our browser and we go to mail.google.com and you enter in your details, a lot of stuff happens underneath the covers. The thing that we all care about is certainly this badge, which I should probably update these slides to show what the current UI looks like, because it did recently change. But historically, when you looked up at the top left-hand corner of your browser, in Chrome at least, you would see this secure badge that would tell you that, hey, this site or something here is secure. And the key thing here is that secure is based off of certificates, the thing that we're all here to talk about today. And it really is telling us that this session is secure, but there's a bunch of assumptions that go into that. Fundamentally, a key part of it is when a client goes to, Google, for example, in this example, will go to a certificate authority to prove to the CA that it owns mail.google.com by going through a process of domain control verification and getting this certificate so that it can then later prove the same thing to somebody else. This is, I generally call this delegated tofu, delegated trust on first use. On the web, we've said we don't want the user to have to verify this. Instead, we're going to delegate this responsibility to a CA. And this allows for the seamless experience that we have today when we go to eBay, Google, or whatever. So now a user goes and visits gmail.com or mail.google.com, and Google presents that certificate to the user, and the user says, that's great, looks like I'm talking to Google, and I'm comfortable to pass my user ID and password to these people so we can log into my account. And this all works great unless a CA makes a mistake. And to err is human, forgive divine. Mistakes do happen. The real measure is how you deal with those mistakes when they happen. And so what happens when a CA makes a mistake? Well, the bad guy is able to get a certificate that says it's mail.google.com, and then they're able to convince the user that it is mail.google.com that they're connecting to, and then they get your user ID and password. And so this makes somebody happy, not the user. It doesn't really make Chrome happy. But then the question is, does this really happen? Everybody in here is probably familiar with DigiNotar. This is probably the largest example, really the thing that led to the creation of certificate transparency. And for those not familiar, a hacker made it into the DigiNotar CA's facilities and had direct access to the HSM and was sitting there minting certificates all day long for login.live.com, the accounts.google.com, and various other websites, and then performed man-in-the-middle attacks. This is not the only example of a compromise. It was just a spectacular example that is easy to see, makes it easy to see the value of something like certificate transparency. So what is certificate transparency? It really is an ecosystem to detect misissuance. My first position when I was at the commercial CA was it's Google's attempt to put themselves at the top of the internet. Of course, my position has changed. That my job is to build that ecosystem now. And I think that I might be a paranoid by profession, and that might explain why I took the position that I did. But really, I think the key word here is ecosystem. So we have logs operated, these entities that we call logs, and I'll explain what they are, operated by folks like DigiCert, Cloudflare, and numerous other people that are used to keep an eye on the certificate issuance practices of the Web PKI, these publicly trusted CAs that are responsible for performing this domain control validation and verification in that delegated tofu scenario that we talked about. And anybody can run them, literally anybody. One of my favorite stories is there was a 16-year-old who was running one out of his garage in Michigan for a few years. And all that really is required, and I'll talk about it a little bit later, is that you can maintain a reasonable uptime and meet some policy requirements that are pretty basic. So if anybody in here is interested in supporting an open and transparent web and would consider operating CT logs, come and find me over the next couple of days. So the basic idea here is that these certificate transparency logs are integrated with the CA issuance workflow, so we have this clear idea of all the certificates that CAs actually issue. And a common question when you hear that is, aren't we just shifting responsibility of trust from CAs to logs? And the answer is actually no. And it's because that what logs do is cryptographically verifiable, where with CAs, we're responsible, or we rely extensively on third-party audits to make sure that things are happening the way that they're supposed to happen. But as an example of how that doesn't necessarily work, you're only required to do 3% sample audit for a portion of web trust, for example. And what is 3%, is that sufficient? And in fact, DigiNotar had valid web trust audits. So sometimes auditors don't do the same caliber of work that they should probably be doing, because incentives are not necessarily aligned well with the interests of the web. They're aligned well with, I want that contract to be finished so I can recognize that revenue, and I want to keep that customer, and I want a new product to sell. And so we can't rely exclusively on these third-party audits. That doesn't mean they don't have value. It just means that we have to make sure we look at the problem a little bit more holistically than somebody I've never met told me it was okay. And that's where CT comes in. And the key component of certificate transparency is that you can verify that they've behaved appropriately. And we'll talk about some examples of where we've caught various entities, including Google, not behaving appropriately, sometimes on accident, which was certainly in the case of ourselves. So the way this works is we've all heard the blockchain phrase or term. Underneath blockchain is this magical data structure called a Merkel tree. And we use Merkel trees in certificate transparency. And what you see here is at the top is something we call a tree head. And we have a hash of these nodes in this graph that allow us to be able to effectively verify that this log has been structured and in accordance to a set of rules that are specified in an RFC. So we can say, you see at the bottom here, we have C4, which is a certificate that was included into this graph. If I wanted to do a verify of this, I can actually take just a branch of this data structure, and I can walk up and verify that this log is complete and has not been modified. This happens, you can see here that if we come back, let's see, I can't really show you, I think. Do you see my mouse? You do, okay. So you can see here that here is our certificate that's been included into the log, and we can see here that its parent is a hash of C5, so C5, and then its parent is a hash of the other things that are inside of this tree, and then its hash is a parent here, so we can walk our way up, and we can see that this branch, all the signatures basically match. And this is what happens when we do signature verification on these, when we're looking at these logs to make sure that the certificate is actually included in the log, and that we can monitor the log for malfeasance or incompetence. And so does this all work? Yes, we've successfully detected misbehaving certificate transparency logs. And some of them were good, or all of them to date have been examples of honest mistakes, but they're honest mistakes that require, sort of like you imagine key compromise, and this is actually the best example of that, I guess, is ISNP, who is running a log, accidentally cloned their production private key for their log to their test environment, and so there were two versions of this data structure out there, one that was from an unsecured environment and one that was from a secured environment. This is kind of the same thing as duplicating your CA private key from your HSM to a disk somewhere. And so this log ended up having to get disqualified. Another one was Venafi, who was running a log, had a outage, and when they restored from backup, they ended up producing two different versions of the truth by restoring from a previous point in time. And so this provided what we call a split view of the log, and they ended up, so this was an example of something that was detected. So we know that this system works for detecting whether or not a log is misbehaving. We also know that this log enables us to find interesting things. We've found issues that I know Dan is dealing with now in regards to semantics issuance practices, amongst many other CAs, because we now have the ability to see the mistakes that are made and it allows us to quantify that risk. But I think the bigger question is, why would anybody actually participate in this ecosystem? And the answer is because browsers have sort of pushed CAs to do so, and Chrome has led this in the context of CT. And as of I believe it was 4 or 5 years ago that Chrome first required to get the EV badge, you had to include the certificates that you issued into the CT logs. And over the last, say, 5 years, we've moved from that, what is between 5 and 8% of all certificates being included in CT logs by CAs to 100% of those that are used on the web PKI being included. And so April 30th of 2018, Chrome went to requiring CT to be used for all DV certificates as well, and DV and OV certificates. So now, if you're not getting an interstitial when you surf a website in Chrome, that means that your issuer has logged that certificate. Safari has also been making slow and steady moves to adopt CT. I believe it was 2 years ago they started to require a specific subset of certificates to be included in multiple certificate transparency logs. They also added support to the iOS platform, I think it was last year, for giving app developers the ability to require that CT be used. And this year they announced next month they're going to require all newly issued certificates to be present in multiple CT logs like Chrome. So now now Safari and Chrome, being two moderately used browsers, I carry an iPhone and use Chrome on my desktop, are all looking at these logs to make sure that there is a consistency, that all the certificates have been registered with the logs, and then looking at the certificates for common issues. There are other browser vendors as well who are actively working towards supporting CT. I just noticed the other day that Windows now, if you look at the certificate viewer, includes a SCT decoder inside of Cert Viewer, and that's a leading indicator of somebody's doing something. So is there a concept of a trusted certificate transparency log? As a general rule, we say they aren't really trusted logs. We talk about them as being qualified logs, and that we don't require logs to, we don't rely on logs as being trusted because we can verify what they do. But for a log to be qualified, it really doesn't need to do very much. It needs to conform to the RFC that describes the behavior of logs. It needs to maintain 99% uptime, which is relatively generous. And it needs to be able to produce a new, basically incorporate every certificate that it has received within 24 hours. This is a very low bar for operating a service that supports the web. It is harder than it sounds, but literally anybody can do it. If a 16-year-old can do it in his garage and support some of the world's major CAs, anybody can do it. As I said, it is harder than it sounds. There was a log called Alpha that failed to incorporate within 24 hours. It took it 36 hours, basically. There is another which is a Google log. Here, we failed to incorporate within 24 hours. There were operational issues that caused us to do this. These are not cases of malfeasance, but just we'll call them lessons learned while operating logs. And while all the examples I have today are just of log problems are accidental, the important thing is that because we're able to detect these accidentals, it demonstrates that we could also detect the malicious act. So if we take this example here where with Alpha incorporated certificate within 24 hours, but couldn't provide proof until 36 hours after submission, that's the window that an attacker had to be able to impersonate that website. And because we could detect that it didn't meet the merge delay, if it was a result of an attacker, which it was not in this case, we would have a point in which we could start investigating and try to mitigate the risk. So we wouldn't have a DigiNotar type event where DigiNotar was owned for an extended period of time. So does CT work? General consensus, even Thomas agrees that it works. So I think we'll just jump to this. So Facebook came out early as an advocate of certificate transparency. Big brands, Facebook, PayPal, eBay, the most fish brands in the world would really like to know if somebody's trying to phish their website. And one of the nice things that CT gives you is the ability to know if somebody's issuing certificates that contain your name. Or even in an enterprise, having worked in enterprise in PKI in the past, I know I always was trying to get everybody to get certificates from my CAs. And then I'd turn around and tomorrow I find out that somebody has been buying certificates from vendor 2, vendor 3, vendor 4, and I'm not managing the cryptographic lifecycle of those, and then there's an outage that happens, but I had no way to figure it out until something broke. What CT gives me as an enterprise user is the ability to keep an eye out for my domain names and find out what certificates have been issued, and then I can go and figure out, was that an employee of my company who did this? And should that certificate be replaced with one that's under management? And now I have a mechanism to do that. And this is actually why Facebook likes certificate transparency, because it allows them to keep an eye out. Is somebody out there issuing certificates that say Facebook in it that are homographs for Facebook, and are people trying to trick users to provide information using our brand as a tool to do that? And this gives them a mechanism to do that. So CT isn't done. There's a lot of things that we want to see happen in CT. One of the things that we've been spending the last, say, 12 months on is improving the robustness of our own CT implementation. Our first implementations of CT were what I would call naive. An example, probably the biggest example, is that we kept all certificates in memory. And when you're Google and you have a big easy button for deploying things where memory is free and you don't really have to worry about those things, it seems on the surface a good idea. But even we ran into issues where all of a sudden, a certain CA started to issue 70 million certificates every 90 days, and that data structure in memory started to get kind of big. And maintaining it in memory forever was probably not the best idea. So we built a new version of our log server code base where we store that information in a database, which has a number of interesting engineering challenges associated with it. But we've retooled, we've solved those challenges, and we are running all of our new logs on that infrastructure, and we're working on migrating our old logs to that same infrastructure and working with third parties to run logs based on this new code base as well. So one example is Cloudflare is running this code base. It's called Trillion. So there's a lot of certificates out there, and I think that there's going to be more. So these logs, they just keep growing and growing, and that's one of the reasons why we retooled the log code base to be able to deal with an infinite size of growth. And we've made some significant improvements. So, for example, we do everything at Google is framed in queries per second, but really it's a transactions per second figure that you see here. 2,000 transactions per second is roughly what we see with a single deployment. We have a ongoing test that when the slide was put together showed that there was 13 billion plus certificates in the log, and it's still going. The number is actually significantly larger than this. And so we believe that this new infrastructure is going to be able to scale to all future needs. The new infrastructure is also designed to be multi-tenant, so one individual server can run a bunch of different logs. And one of the trends that's started to happen as log operators is the switch from running one monolithic log, which we used to do, to having ones that are date sharded. So one log for 2018, one log for 2019, one log for 2020. And this multi-tenancy allows us to do that. And there's some good reasons that we learned over the last 5 years running this infrastructure where that makes sense. One of which is if you run a log that's good for 4 years, and somebody like Let's Encrypt comes along and starts issuing 70 million certs every 90 days, you are maintaining a very big database where you maybe don't want to be able to do that. It's much easier to scale when you have 4 smaller ones than one really large one. And so this is why all new logs have been moving to this date sharded based approach, because it makes it harder to perform a denial of service on these logs. We also retooled this infrastructure so it was more generic, and you can build other transparency applications on top of it. We introduced 2 modes into this infrastructure that we created. One we call log mode, where you have a list of transactions, a ledger like in Bitcoin, or certificate transparency. And another we call map modes, which is more like a database. And this new capability allows us to be able to apply the same Merkel tree to a key value store, this new map mode. And so if you have data now that is not just a simple list of transactions, using this Trillion infrastructure that we use to power certificate transparency, you can build out solutions that'll solve more problems. And of course, there's certificate transparency, which we've talked about. But another example is this thing that we call key transparency. Key transparency is very similar in spirit in that it is a collection of public keys, just like certificates are a collection of public keys. But key transparency is focused on a different use case. It's not about keeping an eye on a certificate authority. It's about how do I securely discover the public key of a peer that I'm going to do a transaction with. My favorite example is iMessage. Today, when you use iMessage, if you're going iMessage to iMessage, it's an encrypted communication, but there's a lookup that takes place where the phone will go and do sort of a select star where phone number equal query to Apple to find out what the peer's public key will be. And Apple can return anything that they want as the public key of the person you're going to communicate with. And there's really no way to verify that it's manipulated its response. That's not to suggest Apple would ever do so. The same exact problem exists in Signal and Wire and various other encrypted messaging apps. But what key transparency does is it makes it possible for both the sender and the recipient to detect changes in this log of keys. And so you can go and look up all of the public keys associated with Ryan, and you can find out what's the current key. You can see of all of those various updates, who added the key to the account. Was it Ryan using a key that he already had, replacing another one, or was it Google helping with a password reset, or was it some malicious third party who inserted something and the signatures don't match? And so key transparency built on top of that same infrastructure allows you to do secure discovery of public keys and be able to detect whether or not there any sort of who did these updates, and that makes it possible to take out the step of verifying thumbprints. So we've all probably read the trailing and leading and trailing hash bits of a hash before to make sure we're looking at the same cert. You can think of this as being a technology that allows you to take that process out of the user experience. Another example of where we're using this is in a DeepMind project. We call this project Verifiable Data Audit. And what, again, on top of Trillion, we've built infrastructure that allows us to track who has accessed individual data. So there's a Wired article on this particular project. If you do a search for DeepMind untrendy blockchain, you will find a brief description of this project. But at a high level, what they're doing with this is they receive some data from the UK health system, and they want to be able to demonstrate to the UK health system when that is accessed and which entities have accessed that information. And they are building their solution on top of Trillion, because it gives them this append-only log structure, this Merkel tree, that allows them to be able to create a cryptographically verifiable proof for data access. Happy to talk about how they've implemented that and what they're doing there. But all of this, the story is on top of Trillion. And our goal with Trillion is to make it a generic platform that we can take the lessons learned from certificate transparency and apply them to key transparency, verifiable data audit, binary transparency, process transparency, and many other sort of things, all on top of the same infrastructure. And so that is that. So in close, Ben Laurie is one of the fathers of certificate transparency, and he doesn't like it when I talk about certificate transparency as a blockchain. And one of the things he's told me once is every time somebody says a blockchain can do X, change it to Merkel Trees can do X for less. And you're less likely to get seed funding, but more likely to get a real solution. And so if there was a tenet behind certificate transparency, sort of retroactively, you might say that that's what we've done here. So that is certificate transparency in a nutshell. That's key transparency, verifiable data audit. But I have some other things that I can talk about as well, changing back to the future of CT. Today, the browsers require that certificates that are issued contain what are called SCTs from a Google log and third-party logs. This is something that Google would like to see change, as well as other browsers would like to see change. And it looks like Thomas would probably like to see the same thing as well, and his Linux hat on. And there's a number of technology things that'll need to happen for that to happen, and we're making investments in that. One of which is we need to get the browsers to do what's called conclusion proof checking. And so today, the browsers sort of rely on the browser operator to make sure that logs are correct. And in an ideal world, the browsers themselves would be doing that work. And there's some engineering work that we're working on to figure out what does it look like to close that loop. And as soon as the browsers themselves are doing that work, it's possible to remove that one Google log requirement, which is something that Google would really like to do. We would like to see CT be infrastructure like DNS that is operated on behalf of the internet and not something that Google is enforcing on people. And the other UAs that are adopting certificate transparency also certainly would like to see that happen. There are other engineering efforts going on testing how we can implement implement this? How do we get these proofs down to the client in a way that is privacy preserving? And how can we provide demonstrated proof that all of these things are actually happening in the way they're supposed to? And I'd be happy to talk about those to folks if they have any questions. But I guess now would be a time to open the floor to questions. Thanks.
So, yeah, we have 2 mics. Admir will have questions that has been passed in through the app. And if there are any questions after that from the floor, I'll go around with the mic to you. Thank you, Ryan, for a very interesting presentation.
Thanks.
We do have a couple of questions here. The one would be if you could reflect a little bit about the operational complexities when running a log server. I think you kind of touched on it in your presentation, but maybe you can reflect a little bit more.
I can. So part of it is, so when you have an append-only data structure, there is not a lot of tolerance for outage. So government websites, I'll give an example. It's maybe a little silly example, but in the US, if the government is shut down for some financial reason or whatever reason, they actually go out and turn off their websites. I think it's ridiculous, personally. It's not like the computers are, can't work when people are on strike, but they go and they turn them off. Or plenty of websites will go down at midnight to go apply updates and things like that. There's not as much tolerance for outage in the context of a log because there is this constant clock. Something has to happen every period for the log to operate correctly. So you have to do a lot of planning to make sure that you have a system that you can update while it's running. And you have to have a lot of monitoring to make sure that problems are detected and responded to quickly. The reality is that it's not as hard as it probably sounds, but basically it needs to be operating 24 hours a day without error. And Trillian makes a lot of that easier. And we have other improvements that we'll be making in the Trillian code base to make it easier still. But basically, because there's this cryptographic ledger, you basically have to be running all the time, and that's the hardest part.
So we have a couple more questions here. Do you have plans for a specific consideration of, for instance, eIDAS directive and qualified website authentication certificates? Then we have also another question that kind of connects on eIDAS. In what form could these logs be applicable to the issuance and trust of personal or organizational certificates, like eIDAS?
So from a user agent perspective, in the Web PKI, quacks are just certificates. And so some quacks are also EV certificates, and that's to the extent that they get any special handling by browsers. That would be the only, it's more metadata in a certificate. In the context of CT, it's agnostic. It really doesn't care. It's just a cert that gets logged. And then I think that should answer both of those questions.
Anybody raise hand? Oh, sure.
So Ryan, I'm just wondering if you've had any experience of other code bases for running a CT log, not playing nicely, perhaps with Trillian code base.
So the question, to the question of other code bases not playing nicely with Trillian, I don't think we've had any examples of that. One of the things that I would like to see is an open source third-party implementation of CT that is robust, as robust and as scalable as Trillian. Because I don't like the idea of a single code base being used to power the internet. But I'm not aware of any code base interoperability problems between Trillian and user agents or any client that interacts with it.
I'll take this as a hint. Comes to the second code base. Do we have any more questions, please? I might be not saying yours. Just please raise a hand.
Thanks, Ryan. My question was around, we'll be talking about post-quantum computing later, also digital signatures. And so to that extent, the XMSS RFC was made, standardized earlier this year. Are you aware of anybody using this platform for the use of the key management of the keys required for XMSS?
I'm not. So I think there's sort of two parts. Today, certificate transparency being geared towards the web PKI, the implementation that exist for it, and there are other implementations other than Trillion. Trillion's just the best because it's ours. But it implements the web PKI policies. So, for example, you can only have an RSA and a SEC B256, or SEC, whichever of the subset of the NIST curves are allowed. So you wouldn't be able to, for example, log a certificate that had one of these other types of keys inside of it today. And that's only because there's policy implemented in code that prevents it. A log does have a responsibility to verify signatures when things come in as well. So there's the component of the logs would need to be able to support doing the verification. But it would be a very, very small project to make it possible, but a production log supporting the web PKI wouldn't be able to support these things until browsers and the CAB forum's policies were allowed to use such algorithms.
So I'm curious, in terms of hosting providers for CT, are they typically today industry, if any, or are they private?
So the people who are running CT logs, the 16-year-old, he's great, but he is no longer running a CT log. He has taken a job. He's no longer 16 too. So I probably will have to stop using him as an example. If you are watching this anywhere, I do think you're great. But the people who are normally running logs are usually big companies. There's no financial incentive to run a log. You don't get to charge money for there's no money to be made running a log. The reason you run a log is because you care about the internet. And so the organizations that run logs typically do so because they see the internet being a secure place as being important for the health of their business. Cloudflare is an example of somebody who is running logs. They will, it is part of their culture to do things to make the internet more secure, and so they take on the operational burden, which is not huge, just so y'all know, of running a log. Some of the people who run logs are CAs. They run logs in part because they want to support the internet, but also because they'd like to have some control of their availability and uptime. And if to issue a certificate you have to get included, at least knowing that you can include it to your own log has some value to you. But I would say the majority of people are larger companies that can commit to long-term operation of something like this, and who have a culture of giving back to the internet.
Well, one more, and then we have to wrap it up.
It's actually, just a follow-up to the last thing. Do you see any point in the future where it might actually cost somebody to actually add their certificate to a CT log?
I would think no. I mean, you don't pay for DNS queries. I think of it kind of in the same way. It certainly is core to our vision of the ecosystem that CT logs are open. And to the extent, as a demonstration of that, it's required that you have a policy on what CAs that you will accept certificates from. And wasn't listed on the slide, but basically if you say you're only going to incorporate certs from your CA, you won't get approved to be embedded into Apple or into Chrome. So I would think probably never, but I would say as a product manager for it would be a failure if we ended up there.
Thank you, Ryan. Thank you very much. One applaud, please, for